Chapter 2, Review of Basic Mathematical Skills. After this chapter is over, you should be able to do the following, which many of you might already know how to do all of this. Number 1, add, subtract, multiply, and divide whole numbers. 2, add, subtract, multiply, and divide fractions, reduce fractions to the lowest terms, and discuss mixed numbers. Add, subtract, multiply, and divide decimals and round them to a specific place value. Convert between fractions, decimals, and percentages. Express numbers in ratio and proportions and solve for unknowns. We will go over the keywords throughout the chapter. Accurate calculation of medication doses and dosages is extremely important for patient safety. The patient depends on your calculations, and the pharmacist expects you to correctly make those calculations. Answers must be precise. Partially correct answers are unacceptable and may endanger patient safety. Basic math skills are essential in pharmacy. Always look at your answer and ask, does it make sense? So that is something that you'll hear me say a lot throughout these lecture videos is when you're doing math, if it just doesn't look right, the number doesn't match, it's bigger or smaller than it's supposed to be, then it's probably something that you need to recalculate. Use estimation and your knowledge in normal medication doses to be sure your answer is within a normal range. And we will see many different relationships between the numbers and just like basic knowledge of things that you should be able to do in your head. So you'll hear me reiterate that, this is something that eventually you should know how to do in your head because if it's this, then it's this. Review the following concepts and skills, paying close attention to the ones you have the most difficulty understanding. And you can ignore where it says do not use a calculator for this chapter. Because you can use a calculator on the PTCB exam or the NHA exam, whichever one you take. You can use a calculator on all of your homework assignments. So this is just saying that you not use a calculator because you can really test your basic math skills. Basic math skills are not going to be asked on the PTCB exam. You're not going to see a fraction problem on an adding and a subtracting fraction problem or anything like that. It's just you knowing these concepts helps you to learn and understand the higher calculation dosage type problems that we'll be doing at the end of the mod. A whole number is a numeral consisting of one or more digits that is not followed by a decimal or fraction. The digits used in math are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Numbers may also be written in words such as 1, 2, 10, 100, 130, and so on. Commas are recommended to be used on medication doses greater than 999 according to the Institute for Safe Medication Practices, the ISMP. Therefore, a dose of 1,000 of heparin units should be written 1,000 units. A whole number is always to the left of a decimal point. The numeral 0 is a whole number with the decimal understood to be at the right side of the 0. When adding, subtracting, or multiplying whole numbers, the answer will always be a whole number. That is not always the case when dividing whole numbers. Any number that remains when numbers are not exactly divisible is called a remainder and is expressed as a fraction or decimal. For example, 10 divided by 2 is 5, but 11 divided by 3 is 3 and 2/3 or 3.6. 11 and 3 are whole numbers, but they're not evenly divisible, and the answer is expressed including a fraction or a decimal. When adding or subtracting whole numbers, align the digits from the right and then add or subtract one set of digits at a time, starting from the right, from ones to tens to hundreds, etc. Addition is finding a sum or total of numbers. Subtraction is finding the difference between two numbers. So example 2.1, we're not going to do any workouts because there's four different math and subtraction problems here. They're already lined up if you wanted to do them by hand. But all you have to do is simply just get out your calculator and add and subtract those to get the answer. So hopefully all of you know how to do that. However, if you don't, please reach out to me as soon as possible so we can find a solution on getting you caught up with basic math. Multiplying whole numbers. When multiplying whole numbers, align the numbers or factors as you would for addition or subtraction. The use of X or that period denotes that the number should be multiplied to find a product. Remember that a number multiplied by zero is zero. First, multiply the number on top of the problem by the number at the far right of the bottom of the equation. Place the ones digits of this answer under the line and carry the tens digit to the next place. Multiply the remaining number and the subsequent digits moving from right to left, keeping the numbers in alignment. Move to the next number to the left in the bottom number and repeat the process. Remember that the second number is already in the tens place, so it must be placed one space to the left of the first answer. Sometimes it is helpful to place a zero in the ones place to keep the alignment. Finally, add the numbers that have been multiplied to obtain the product. All right, so for examples 2.2 and 2.3, all you're doing is taking out your calculator and doing 125 times 15 to get the answer. And then for example, 2.3, you're multiplying 225 by 10. If you want to do them by hand, it's already set up for you as an example, so you can definitely do that. Dividing whole numbers. Division is represented by either of those signs. The number being divided is called the dividend, and the number used to divide is the divisor. The result of division is the quotient. So it gives a nice setup of how those go for long division. You can use your calculator for this problem, example 2.4. You're going to get a straight answer, so you don't need to really worry about long division. You will see me use it in some of the examples, though. A proper fraction is one in which the numerator is less than the denominator and is part of a whole, such as 2/3 and 5/8. Its value is always less than 1. An improper fraction is a fraction in which the numerator is greater than or equal to the denominator, making the fraction equivalent to or greater than 1, such as 9/8 is equal to 1 and 1/8, and 14/7 is equal to 2. If the numerator and the denominator are the same, the value is 1, such as 9/9 is equal to 1 and 10/10 is equal to 1. An improper fraction can be changed into a mixed number, a whole number, and a fraction because a fraction indicates division. The numerator divided by the denominator when A over B or A/B is written. The fraction actually means A divided by B. So that's something really important to remember. And I'm just going to highlight it because we're going to use that a lot in our calculations that we do further along in the. To convert or change an improper fraction to a mixed number, divide the numerator by the denominator. Any remainder is written over the denominator. So we will do example 2.5.
All right, so example 2.5, convert the improper fraction 43/8 to a mixed number. So this is the one part where we will have to know long division. So we're just gonna go 8 into 43. Eight goes into 43 evenly 5 times. So 40, and then we have 3 left. And then we carry, so our 3 is here, and we carry that 8 over here. And our answer is 5 3/8. Example 2.6, convert 4 1/8 to an improper fraction. So what we're going to do for this one is we're going to take the denominator and multiply that by the whole number. So 8 times 4 is 32. Then we're going to add this top number. So 33. And we keep the denominator the same. So 33/8.
Reducing fractions to the lowest terms. Some fractions called equivalent fractions have the same value. The fraction 1/2 is equivalent to 2/4, 3/6, or 50/100. With 2/4, the numerator and denominator can both be divided by 2 to give 1/2. With 3/6, both parts of the fraction can be divided by 3 to give 1/2. With 50/100, both components of the fraction can be divided to give 1/2. Each of these fractions is actually 1/2 of the total number of equivalent parts of a whole. When reducing fractions, the numerator and the denominator must be divided by the same non-zero number. For example, 3/12 can be reduced to 1/4 by dividing the numerator and denominator by 3. Dividing by 3/3 is the same as dividing by 1, so it does not change the value of the fraction. A fraction is reduced to the lowest terms when no common number will divide into both the numerator and denominator both evenly. Adding and subtracting fractions. When adding or subtracting fractions, the denominators must be the same. Once the denominators are the same number, the numerators may be either added or subtracted. The denominator remains the same. So let's do example 2.7.
Example 2.7. So this is pretty simple, adding and subtracting in terms of fractions. So we have 3/5 plus 1/5. We have the same denominator, so we don't have to worry about anything. We just have to add the 3 and the 1, and we get 4/5. Example 2.8 is the same as the previous example. We have a subtraction problem, but they're the same denominator. So we can just rewrite them like this. And we know the 5 is going to stay the same. 3 minus 1 is 2. And that's obviously what they have as their answer. So 2/5.
Finding common denominators. If the denominators are not the same, the smallest whole number that can be divided evenly by both denominators within the problem is needed, the least common denominator. Sometimes the LCD is easily found because one denominator can be divided by the other. Since 15 is divisible by 5, it is a common denominator for 3/5 and 2/15. To change fractions to their equivalent fractions for adding or subtracting, first find the lowest common denominator, then multiply the numerator and denominator of each fraction by the fraction equaling 1. That will make the denominators equal to the lowest common denominator. Then add or subtract the fractions by adding or subtracting the numerators and leaving the denominator the same. Let's do example 2.9.
Example 2.9, we have two fractions, 3/10 and 2/15. They do not have the same denominator, and we need to subtract them. So we have to find the lowest common denominator between the two. So the lowest number that they both will evenly divide into by. So looking at those, 10 and 15 can't go into 10, so I'm thinking it's gonna be 30. All right, so now to do this, I'm gonna go 15 divided by 30 is 2. So 2 times 2 is 4. And then here, 10 goes into 30 3 times. And again, I'm not using my calculator, but if you need to, you totally can. And that is 9/30. So now I just need to subtract 9 minus 4, which is 5. 5 over 30. And then I need to reduce that to lowest terms. So I'm going to divide 5 into each. I think that will give me the lowest. 5 divided by 5 is 1, and 30 divided by 5 is 6. So the answer is 1/6. Example 2.10. So we have an addition problem, but we have a mixed number. So it would be nice if we didn't have to deal with a mixed number, we could just deal with the two fractions, but we can't. So we need to turn that mixed number into an improper fraction. So to do that, we're going to multiply the 8 by the 3 together, which is 24. And then we're going to add 5 to that, which gives me 29. And then we keep 8 the same. And then, so now I have 29 over 8 plus 3/4. Now I need to find the lowest common denominator between 8 and 4, which 4 goes into 8, so we'll do 8. 4 goes into 8. 8 divided by 4 is 2. 3 times 2 is 6. 8 goes into 8 once. 29 times 1 is 29. So now we would just add the 29 plus 6. We get 35 over 8. Now we don't want to leave that improper, so we need to turn it into a mixed number by going 8 divided by 35. So 8 times 5 is 40, so it can't be 5. 4. 8 times 4 is 32. 35 minus 32 is 3. That is our numerator, and we keep the 8 the same. So the answer is 4 3/8.
Multiplying fractions. To find the products of fractions, multiply the numerators and the denominators. The product should then be reduced to the lowest terms. Multiplication of fractions does not require a common denominator. Okay, so let's do example 2.11.
Example 2.11, so we have multiplication. Multiplication is really simple. All we're gonna do is so they have it written here like that. 5 times 3 is 15, which they have there, and 6 times 5 is 30. So we have 15 over 30. And we just need to bring that down to lowest terms. So let's try to divide 15 by into these. So 15 divided by 15 is 1, and 30 divided by 15 is 2. So the answer is 1/2.
Dividing fractions involves inverting the divisor, the second number in the expression, which is the number to the right of the division side, so that the numerator becomes the denominator and the denominator becomes the numerator. In simpler terms, the numbers switch places. For example, if 4/5 is inverted, the fraction would become 5/4. This is also often called taking the reciprocal of the divisor. After inverting the numerator and denominator of the fraction to the right of the division sign, continue with the steps as for multiplication. Multiply the numerators and multiply the denominators, placing the products with the numerators over the denominators. Finally, reducing the resultant fraction to the lowest possible terms. So we'll do that example now.
Example 2.12. So we have a division problem. So division is the same as multiplication, but first we need to rewrite it as 4/5 times, and then the next fraction we need to switch the numbers around, invert it. So 10/5. So we'll just multiply across. So 4 times 10 is 40, and 5 times 5 is 25. So if we turn this into a mixed number, 25 can only go into 40 evenly once. 40 minus 25 is 15. So then we get 1 and 15/25. That 15/25 can also be further reduced. I know it's so fun. Let's try 5. So we'll do 15/25. 5 divided by 15 is 3, and 5 into 25 is 5. So our answer is 1 3/5.
Complex fractions are fractional expressions in which the numerator, denominator, or both are expressed as fractions or decimals. This will be covered again in later chapters when we talk more about medications. So we'll just talk through it for now. We have example 2.13. So 1/4 can be multiplied by 4/4, which is 1, to convert it to 1/2. 1/4 can be written as 1/4 divided by 1/2 and then inverted and multiplied to get 1/2. 0.4/60 can be multiplied by 10/10 to form the fraction 4/600, which reduces it to 1/150. 0.4/60 can be written 4/10 divided by 60/1 and then inverted and multiplied to 1/150. Decimals are actually fractions with a denominator of 10, 100, or 1,000, or any multiple of 10. Decimal numbers may include a whole number, a decimal point, and the decimal fraction. The metric system, the most frequently used measurement system in the medical field, uses decimals. Examples of decimals include 0.1, which equals 1/10, 0.01, which equals 1/100, or 0.001, which is equal to 1/1,000. To avoid errors in the medical field, a decimal less than 1 should always be written with a leading zero, a zero in front of the decimal point. For example, the decimal 0.25 should be written as 0.25 and 0.5 as 0.5. A medical professional should never write 0.25 or 0.5 because the decimal can be overlooked, leading to an overdose, which could be fatal. To write decimals using word names, the number to the left will be a whole number, and the decimal point becomes the word and with the number to the right of the decimal place, followed by the place values of the decimal ending with PH. So we have a little chart here. I do have a chart on the basic math study guide. I'll show you that at the end. But you can read through that. And it'll kind of give you an explanation. Zeros at the end of a decimal are trailing zeros and they do not change the value of the number. Trailing zeros are on the Joint Commission's do not use list and will not be used in pharmaceutical calculations because of possible interpretation errors. 1.250 has the same value as 1.25, so it can also be read as 1 in 25 hundredths. To compare a decimal, the decimal amounts must be aligned at the decimal point and zero should be added so that the numbers following the decimal point contain the same number of decimal places. This is important in the comparison of medications in the metric system of measurement. Example 2.14 says to compare 0.125, 0.25, and 0.5. 0.125 may appear to be the largest number, but when the numbers are aligned and the proper zeros are added for numbers to have equal decimal places to the right of the decimal point, this proves to be incorrect. So you can see where they added the trailing zeros at the end to show you which one. Adding or removing trailing zeros does not change the value, but it makes the numbers easier to compare. The largest number is really 0.5 and not 0.125, which might not seem apparent without the added zeros. Note that the decimals are less than 1, so a leading zero was added to ensure that the decimal point was not overlooked. When calculating doses of medication, decimals may need to be rounded to a specific value. Accuracy in calculating to a particular decimal place is necessary in some circumstances, whereas rounding or approximating is acceptable in others. For example, if 18 units of subcutaneous insulin U100 are ordered, the volume given must be 0.18 milliliter. It cannot be rounded to 0.2 milliliter. If an oral medication dose is calculated to be 3.99 milligrams, and a 4 milligram tablet is available, the patient would receive one tablet by rounding to the whole number 4. And you should only round the final answer when performing multi-step calculations. Steps for rounding. Step 1, underline the digit in the place for rounding. Step 2, look at the digit to the right of the underlined digit. If it is greater than or equal to 5, round the underlined digit to the next highest number and drop all digits to the right. If it is less than 5, drop all digits to the right of the underlined digit and keep it the same. All right, so example 2.15, round 1.16 to the tens place. So 1.16, the 6 indicates that the number to its left should be rounded up to 1.2, and then round 1.14 to the tens place. 1.14 indicates that the number to its left is to stay the same, or 1.1. Adding and subtracting decimals requires aligning whole numbers and decimal points. After aligning the decimal points, add zeros at the end of the decimal fraction until all decimal numbers are to the same decimal place. Then just add or subtract as you would for whole numbers, remembering to correctly place the decimal point in the answer. So we can just take our calculator and figure this out really quickly. But this is showing how, if you're doing it by hand, how you would add the trailing zeros so you can align all the numbers together and easily figure it out with pen and paper. Multiplying decimals is similar to multiplying whole numbers. The alignment of the numbers is identical without regard to the placement of the decimal. The difference is the proper placement of the decimal after the product has been calculated. After the product is calculated, count the number of places to the right of the decimal points and both of the numbers that were multiplied. Finally, place a decimal point in the product by counting from right to left the number of decimal places found in both elements to the problem. So again, for our sake, we can just make it easy and plug those numbers into a calculator. This is just showing how you would do it again on paper or pencil. Because trailing zeros may be removed from a decimal number without changing the value, remove them and then multiply. Dividing decimals. Dividing decimals is much like dividing whole numbers. Write the problem as for long division. If a decimal appears in the divisor, move the decimal to the right until the divisor is a whole number. Then move the decimal point in the dividend the same number of places to the right. So again, for example, at 2.18, we have a calculator, so we don't have to figure that out by hand for this example. When we have to do them by hand, you will see in the examples. Same with example 2.19. Just use your calculator to get that answer. And same with example 2.20. So you can see all of the workout if you want to practice doing it on your own. A decimal point separates the whole number that appears to the left and the decimal fraction that is found on the right. To convert a decimal to a fraction, the numerator is the fraction following the decimal point and the denominator is a power of 10, dependent on the number of digits following the decimal. For example, 3.7 is 3 and 7 tenths. The 7 is placed over 10 because there's one place value after the decimal in 3.7. The decimal 0.71 would be 71 over 100 because there are two place values after the decimal. Whereas trailing zeros do not need to be counted as place values, zeros following the decimal point and zeros between two whole numbers of a decimal fraction must be counted as place values. For example, 0.05 has two place values, so the fractional equivalent is 5 over 100, and 0.505 has three place values, so the fractional equivalent is 505 over 1,000. Converting fractions to decimals. To convert fractions to decimals, divide the numerator by the denominator. So of course it gives you the workout in words, but let's just take our calculator and do 1 divided by 2. That gives us 0.5. 3 divided by 4 gives us 0.75. And you can do that with any fraction. So 1 divided by 15. 1 divided by 200, and so on and so forth. To convert to a fraction, drop the percent sign and write the number over 100. The denominator will always be 100. Reduce the fraction to its lowest terms. And let's do the example 2.2. 2. Example 2.22, we're going to change 16% to a fraction. So we're first going to just take that 16 and place it over 100. And we do that because percentages are out of 100 always. And we want to find a number that is evenly divisible by both. So I am going to suggest 4. So let's try that. So 16 divided by 4 is 4. And 100 divided by 4 is 25. And that's our answer. Change 2.25% to a fraction. So we're going to take that 2 and 2/5. We're going to turn that into a mixed number. And to do that, we are going to take this 5, multiply it by the 2. So 5 times 2 is 10. And then we're going to add that 2 there. So we get 12. And we keep our 5. So we have 12 over 5. All right. So we are going to take that number and divide it by 100 like we would a normal percent to fraction problem. But instead of using our calculator, I am going to rewrite that as 12 over 5 and divide it by 100. Now remember, 100 is the same thing as 100 over 1. And to divide two fractions, I need to flip this number here. So I'm going to rewrite it as 12 over 5 times 1 over 100. Do the math across. 12 times 1 is 12. 5 times 100 is 500. And then I want to reduce this to lowest terms. I think 4 is going to be it. And if you don't know offhand, then you just try a bunch of different numbers until you get the lowest, and you can keep going lower if you have to. So 500 divided by 4 is 125, and 12 divided by 4 is 3. So our answer is 3 over 125.
Example 2.24, we're changing 8% to a fraction. Only thing here different is we have a decimal. So if you look at the example in the book, it kind of shows you a little bit of a confusing way to figure it out. So I'm just going to rewrite it as 0.5 out of 100, which is what we do to turn percentages into fractions. And obviously we can't leave it this way. But if we divide both of these numbers by 0.5 on the top, 0.5 divided by 0.5 is 1. And then 100 divided by 0.5, I've already done the calculation, is 200. So that's our answer, 1 over 200.
Converting a fraction to a percent. The denominator in a percent is always 100 because any percent is part of 100. And the number besides the percent sign becomes the numerator. To convert a fraction to a percent, multiply the fraction by 100 or by 100 over 1, a fraction for 100, and add the percent sign. This is the same as changing the fraction to a decimal and moving the decimal place to the right two places. So let's do example 2.25.
Example 2.25. We have, we're going to convert 1/5 to a percent. So 1 divided by 5, this is how I do it. So first I take that fraction and do 1 divided by 5, and I get 0.2. And then I need to multiply that by 100 to get my percent. So this is how they set it up. I think that's a little more confusing, but whatever way is best for you. And then we get 20%. So example 2.26 is the same thing. So we have a fraction, we're turning into a percent. Only thing is we have a mixed number. So you can see here, they've already done the math. 13 over 5 is our mixed number, and then we would just multiply 13 by, or sorry, we would divide 13 divided by 5. And then we would multiply that by 100. So 2.6, and then multiply that by 100, and we get 260%. So you can see here how they did that. This is how I do it. So whatever way is best for you. And if you need a refresher on how to do this, remember 5 times 2. So you take the numerator, multiply that by the whole number. That's 10. You add the numerator. Sorry, that's the denominator. You multiply the denominator times the whole number, and then you add the numerator and you get 13. You keep the denominator the same.
To convert a percent to a decimal, drop the percent sign and divide the number by 100. Dividing by 100 is the same as moving the decimal point two places to the left. So you can see here, they, for example, 2.27, 25%, they took the 25 and put it over 100. And then they did in their calculator 25 divided by 100, and they got 0.2. And that would be the same with this. To convert a decimal to a percent, multiply by 100 and add a percent sign. Multiplying by 100 is the same as moving the decimal point 2 places to the right. So example 2.32, express 0.50 as a percent. So again, we're just going to take out our calculator and do what it said. Multiply the number by 100. And we get that is 50. We add a percent sign, so 50%. A ratio indicates the relationship of one number to another or one number to a whole. A ratio expresses a numerator and denominator separated by a colon rather than a division line found in fractions. Numerators are to the left of the colon and denominators to the right, such as 1 to 2. The colon is the traditional way to write a division sign in a ratio and is representative of per, to, or in. For example, 3/4 as a fractional expression would be 3/4 as a ratio. In like a fraction, a ratio may be reduced to lowest terms. Because of the relationship of the numbers in a ratio, the value of the ratio will not be changed if both the numerator and denominator are multiplied or divided by the same number. Multiplication and division are the only numeric operations that can be performed on a ratio without changing its value. To change a percent to a ratio, express it as a fraction. The denominator will always be 100 and change the format. So 30% is equal to 30 over 100, which is the same thing as 30 to 100. To change a decimal to a ratio, express it as a fraction and change the format. 0.09 is 9 over 100 or 9 to 100. When numbers expressed in ratio form are used to compare quantities, one number related to another, they must be expressed in the same units of measure. So let's do example 2.33. Establish a ratio of 3 inches to 1 foot. So we want to have the same units of measure. So 1 foot must be changed to 12 inches. 12 inches equals 1 foot. So that would be 3 inches to 12 inches. Since both sides can be reduced by 3, the unit of inches is canceled and no unit is required in the reduced ratio. So that is 1 to 4. When numbers expressed in ratio form are used to describe one number as a part of a whole number, they may have different units of measurement. In pharmacy, ratios are used in this manner. For example, a milligram is a measurement of weight or mass, and milliliters is a measurement of volume. So one cannot be converted to the other. The relationship is the number of milligrams in or per milliliter. And example 2.34 says establish a ratio for 5 milligrams per 125 ml and reduce. So we would write that as 5 milligrams to 125 milliliters as a ratio. We would then turn it into a fraction and reduce to the lowest terms, which would mean we would divide both of them by 5, giving us 1 milligram there and 25 milliliters as a final answer. So 1 to 25. A true proportion is an expression of equality between two equivalent ratios, such as 4 to 8 and 6 to 12. Placing these in a proportional equation, 4 to 8 6 to 12, or fractional equation, 4/8 is equal to 6/12 is read 4 is to 8 as 6 is to 12. And these pairs of numbers, the relationship between 4 and 8 is that 8 is twice as much as 4, and the relationship between 6 and 12 is that 12 is twice as much as 6. Therefore, these ratios are equally proportional to each other, although the numbers are not the same. Both can be reduced to 1 to 2. When validating proportional equations such as 4 to 8 is equal to 6 to 12, multiply the two outside numbers, the extremes, and the two inside numbers, the means. So 4 times 12 and 6 times 8. Because both numbers are 48 is a true proportion. The product of the means will equal the product to the extremes in a true proportion. To verify this equality when written as fractions, cross multiply both because both answers are 48. It's a true proportion. So that's one way that makes it nice for us in the medication world is that we can double check our answers by cross multiplying and talk more about that as time goes on. But when writing the proportion in the form of A over B is equal to C over D, like units of measure must be in positions A and C and in positions B and D. When the proportion is designated in the following manner, 125 milligrams over 5 ml is equal to 25 milligrams over 1 ml. Positions A and C are in milligrams and B and D are in milliliters. Solving for unknowns using ratio and proportion. In the healthcare field, the ratio and proportion method is often used to calculate different quantities of medications or to calculate doses. Knowing three of the four parts of the proportion is necessary to solve for the fourth. Proportional equations are used to find the missing or unknown amount, often represented by x. The relationship is set up using the fractional method and solved using cross multiplication followed by division. This method will be used in this text when it comes to solving for the unknown value. Ratio and proportion calculations are one of the two main methods used in pharmaceutical calculations. So what we're about to learn is basically pretty much the main thing that we do in math for pharmacy, and learning it is going to be inevitable. Once you get it down, it will make your life so much easier. So let's do example 2.35. All right, example 2.35. We are going to cross multiply and we're going to start with the x. So 35x is equal to 5 times 28. So we're cross multiplying both sides. That's how we get the 35x. And then the other side, we do the two numbers diagonally, which is multiplication. So 5 times 28. Now we're going to do the side where the multiplication is first. So 5 times 28, which gives us 140. And then I'm going to rewrite this side over here. So I have 35x is equal to 140. I want to get x alone. That's what I'm solving for. So I need to get rid of this 35 on this side. Crosses out. And then I just have x alone here. But I also have to do the same thing to the other side. So I need to divide that 140 by 35. And I get 4. So x is equal to 4. Now, if I erase this here, let's just write in the 4 here. And if I cross multiply both of these, I should get the same answer. So 4 times 35, 140. 5 times 28, 140. And we know that That is the correct answer. Calculating with percents, determining the percentage of a quantity. Computation of a given percentage of a quantity may be determined in order to ascertain the part of a whole quantity that is in question. If a percentage of a whole quantity is in question, the known amount is changed to decimal form and multiplied by the whole quantity to provide the needed information. The equation for finding a percent of a quantity follows. Amount equals the percent required, written as a decimal, times the whole amount. So let's do example 2.36. All right, example 2.36. What is 3% of 42? So we do have the formula up there. The amount is equal to the percent required written as a decimal times the whole amount. So we need to change this 3% into a decimal. And so we do that by putting 3 over 100 and then taking out our calculator and doing 3 divided by 100, which is 0.03. 0.03 times 42 will give us the amount, which is 1.26. Example 2.37 is a little different because we are being asked of what. So 15 is 60% of what number? So we're going to use our formula, but we're going to put in things differently. So we already know the amount, right? That's 15. So 15 is equal to the percent required, which is 60. But remember that we have to change that percent to a decimal. So we're going to do 60 divided by 100, which gives us 0.6. So we will write that in our, and then we don't know what the number is. So we're going to do times x. Now we want to get x alone. So we need to get rid of that 0.6, right? So we're going to do 0.6 on this side and then also 0.6 on this side. This cancels out. And all we have left on this side is x. Now on this side, we need to do 15 divided by 0.6, which gives us 25. So 15 is 60% of what number? And that is 25. Example 2.38. So the way this one is written, 15 is what percent of 45? We have to do it differently as well. So we would start off by using our formula up there, but we already know what the amount is, which is 15. So 15 is equal to the percent required. We're trying to find out what percent that is. So that's going to be our x. And then now we're going to multiply that by 45. So we need to solve for x. So to do that, we need to, on this side of the proportion, get rid of 45. So we're going to divide that. And on this side, we have x alone. But over here, we need to do 15 divided by 45. Do the same thing on both sides. And we get 0.333. And we need to turn that into a percent, remember? So we need to take that 0.333 and times that by 100%, which gives us 33.33%. Another method of working with percents is to use the knowledge that a percent is always an amount out of 100. One of three known values will always be 100. A ratio and proportion equation can be set up to solve each of the previous questions as shown in the examples below. So you can see them there. We won't work them out again. They're the same answers. Before continuing to another problem, always ask yourself the following question. Does this answer make sense? This is extremely important in pharmacy math. You will need to use your knowledge of specific medications when asking this question. When an answer is off by only one decimal point, the patient would receive either 10 times too much or 10 times too little medication. This is potentially very dangerous. In addition to using your knowledge of drug doses, estimation is a good way to check mathematical calculations. Estimate a number, mentally round it to a slightly larger or smaller number containing fewer numerals. Then perform the calculation, mentally knowing that the answer will be slightly higher or lower than the actual calculation, but will be close to the desired answer. For example, 12.2 times 3.8 could be thought of as 12 times 4, which equals 48. If your answer comes out closer to 5 or 500, you would know you made a decimal placement error. This process can help avoid many calculation errors. Reducing fractions to the lowest term. So before I go on, I just want to show you, I did bring up the basic math reference guide, which again, you should be able to find in your weekly study materials or your homepage. But I do have all the rules here, how to find the lowest common denominator, how to convert an improper fraction to a mixed number,